the class of Technomathics. So today we have taken some question of electricity where the equivalent resistance need to be calculated. Okay. Here into this question it has been given that the circuit is connected like this, right? And we need to find the equivalent resistance. Here we have five resistances, 1, 2, 3, 4, 5, and all these five resistances are connected as shown into this diagram. What is the effective resistance between the point A and point B? This is the numerical which we have with us, right? And let me mark it. This is a question from JEE, IIT JEE, right? So such questions are coming into the examination, and to solve it, what are the basic concept which we need to apply? We can see that, right? So before just solving this question, I want to take you through the Wheatstone bridge, a balanced Wheatstone bridge. What is that? That if a bridge is looking like this, two series connected resistances, in between it is tapped with one another resistance, and similarly the bottom line, right? When this bridge is visible to you anywhere, just consider it as a Wheatstone bridge, right? And when the Wheatstone bridge application will be applicable, that need to be understood. So for any such bridge, okay, we need to understand, if you remember, that if R1, R2, R3, R4 were the four resistances, and there is a galvanometer which was connected into the tapping point. This is the tapping loop or the loop way. Okay, in this way the galvanometer G is connected across these 2 points, right? Then, and when a battery will be connected across the point A and B, right, then you can say that in such condition, when the values of these resistances R1, R2, R3, R4 are such that the ratio, the you can see that there is no current is flowing through this galvanometer. In that case, if you remember, the bridge was balanced, right? When the bridge was balanced, then there will be no current flow through the middle branch or the tapping loop, right? So we can say that in that case, we have already seen into the Wheatstone bridge that the ratio of these two resistances, that means R1 and R2, will be equal to the ratio of R3 and R4, where this is R1, this is R2, this is R3, and this is R4, right? If you remember Wheatstone. So just I recollected all Wheatstone bridge concept over here, right? So this is a question from the application of the Wheatstone bridge, right? So here, just when such question is coming in front of you, just simply take this R1, take this R2, and just find out the ratio of that. So here R1 by R2 will be equal to this 2 ohm by 4 ohm. Not, I'm not writing ohm, it's 2 by 4, which is coming as 1 by 2, right? So this number you just remember. Now here, what is the value of R3 by R4? R3 by R4 will be nothing but the ratio of 3 to 6, right? So this is coming as 3 by 6, so which is further simplified as 1 by 2, right? So here you can see this 1 by 2 and this 1 by 2 both are equal, so we can say that ratio of R1 by R2 and R3 by R4, both of these are equal to 1 by 2, right? So we can say this as Wheatstone bridge, right? So in this concept, there will be no current flowing through this branch, no current, the current through this tapping branch will not be flowing through, right? Hi TTV light boy, hello. So here you can see when no current will be flowing through it, then the above circuit will be simplifying as this is the question from application of Wheatstone bridge, right? So we can say this above circuit will can be simplified as this R1 2 ohm connected directly with this 3 ohm, which is nothing but your R3, right? And this 7 ohm effectiveness will not be considered because no current is flowing through it, right? Just use the concept of Wheatstone, which we have already deducted. And into the and 2 and 3 are parallelly will be parallelly connected with this 4 and 6. So that's why this 2 and 3 will be parallelly connected with this 4 and 6, right? So the above circuit will be simplifying as this 4 ohm and this 6 ohm. Here we have B, or we can say here we have A, right? So this is very simple, very simple. Here 2 and 3 are series connected. So what is the equivalent resistance? Just simply add it. So this will be coming at 2 plus 3, that is 5 ohm, right? Because for a series connected circuit, it's always add up. And into the bottom line, we have two resistances of 4 and 6. So this is 4 and this is 6. If you remember our circuit, this 4, this 6, right? So this is 4 and 6 will be adding up, and this will be giving you 10 ohm, right? And this is the tapping point B, right? Now here you can see 5 and 10 are connected in parallel, right? When connected in parallel, then what will happen? The equivalent resistance between A and B can be identified as this just as 1 by R equivalent equal to 1 by 5 plus 1 by 10, right? So this will give you the value of R equivalent between A and B as 5 into 10, which will be into the denominator, and R equivalent is also into the denominator. So that will be 5 into 10 by 5 plus 10. I am not going into detail. It's very simple. You already know it, right? Now 5 into 10 will be 50 ohm. 50 ohm divided by 5 ohm into 10 ohm. This will be ohm into ohm. 2 times ohm will be coming into the numerator, and into the denominator 5 plus 10 both are ohm. So only addition is happening, no multiplication. This will be giving you 15, right? 15 ohm. So here 1 ohm and 1 ohm will be cancelled out, and we are left with 50 by 15, which can further be 5 10 times and 5 3 times. So 10 by 3 ohm is the equivalent resistance between the points A and B, right? And this is your answer, which can be further simplified as 3.333 bar. This much of ohm is the value of R equivalent, right? So students, 3.33 or 10 by 3 ohm is the equivalent resistance for the given circuit. Okay, so our answer, that is R equivalent between this A and this B, is equal to 10 by 3 ohm, right? And this is your answer, students. Thank you so much for watching. Take care. Happy learning. Bye bye. See you.